Hello students, now we are going to start the next part. In the last part we have discussed up to this property tan inverse x plus tan inverse y equal to tan inverse x plus y by 1 minus xy. Now we will continue the second part of this question now. Case 2, when x is greater than 0 and y is greater than 0 and xy is greater than 1, then how will this property become? Tan inverse x plus tan inverse y. That is, x is greater than 0 means what is tan inverse x? It lies between 0 to 90 degrees. We already learned this. And y is greater than 0 means again tan inverse y will also lie between 0 to 90 degrees. Now let tan inverse x be alpha and tan inverse y be beta. It is just like the previous time. Now when we add these two, then tan inverse x plus tan inverse y will lie between 0 to 90, 0 to 90. So total 0 to 180 degrees. Alpha plus beta will be between 0 to 180 degrees. Now what we need to see is, alpha plus beta is between 0 to 180 degrees, and what is tan alpha plus beta? Tan alpha plus beta will lie between, let me do it here. Alpha is tan inverse of x and beta is tan inverse of y. And what is the condition given? X is greater than 0, y is greater than 0 and xy is greater than 1. xy is greater than 1. Now how to find this? Alpha plus beta. Alpha plus beta is tan inverse x plus tan inverse y. This value lies between 0 to 90 degrees. So final answer, alpha plus beta lies between 0 to 180 degrees. Then what is this? Tan of alpha plus beta. Tan of alpha plus beta. Tan alpha plus beta is equal to, what is the formula students? Tan a plus b is tan a plus tan b. Tan alpha plus tan beta divided by 1 minus tan a tan b. 1 minus tan alpha tan beta. Okay, this is the formula. And what is this value? Tan alpha is nothing but x plus tan beta is y divided by 1 minus xy. Now what is given? xy is greater than 1 and x and y are both positive numbers. That means this term is positive quantity and xy is greater than 1. That means this whole value will be negative quantity. So positive number divided by negative number, that is negative. This answer is less than 0. So what we understand? This tan value is less than 0. When tan will be negative, alpha plus beta is between 0 to pi means in first quadrant tan is positive and in second quadrant tan is negative. Final answer is in negative. So this answer tan alpha plus beta is in second quadrant, which means alpha plus beta lie between pi by 2 to pi. Is that correct? Alpha plus beta lie between pi by 2 to pi. Only in second quadrant tan value is negative. So what we understand from this? This is nothing but tan inverse x plus tan inverse y lie between pi by 2 to pi. Now how to find the answer for the given question? What is the property? Tan inverse x plus tan inverse y. When we add tan inverse of, that is final answer should be lying between minus pi by 2 to pi by 2. That is the range of tan inverse. But here what we get? Pi by 2 to pi. We should get the answer between minus 90 to 90. But here we got answer between 90 to 180. So what we need to do is, Just subtract 180 from this. That will give us the answer between minus 90 to 90. So we just need to write this answer minus pi plus tan inverse of. That will be the required answer. I hope this is clear now. Here just observe the angle. Angle is between 90 to 180. So what we need to do is tan of alpha is between negative value, but final answer should be in between minus pi by 2 to pi by 2. So we need to convert this in terms of in the angle that matches with this tan alpha plus beta in the value in the range of minus pi by 2 to pi by 2. As this is negative, if we add minus pi, that will give us the answer in the value in the range of minus pi by 2 to pi by 2, and the value will exactly match because tan of pi plus alpha is again tan alpha. So final answer is we have to add minus pi to this. So this answer becomes alpha plus beta minus pi is equal to this value. So final answer alpha plus beta will be pi plus tan inverse of this. So final answer is alpha plus beta equal to pi plus tan inverse of x plus y by 1 minus xy. This is the proof for this statement. Next we will solve few problems and go to next chapter. Okay. Question: find the value of tan inverse 1 by 2 plus tan inverse 1 by 3. First step is to identify what is the formula to be used. Here this is of the form tan inverse x plus tan inverse y. Now what we need to observe? This value is greater than 0. Let this be x and let this value be y. That means x is greater than 0 and y is also greater than 0. What is xy? Xy is 1 by 2 into 1 by 3, that is 1 by 6, which is less than 1. X greater than 0, y greater than 0 and xy is less than 1. Now after establishing this condition, we should see which formula to be used. So as this condition is satisfied, tan inverse x plus tan inverse y is equal to, what is the formula, students? Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Just substitute in the value. This is equal to tan inverse of 1 by 2 plus 1 by 3 divided by 1 minus 1 by 2 into 1 by 3. That is equal to, this value is actually 5 by 6 divided by 5 by 6. Tan inverse 1, this is nothing but tan inverse of 1, which is nothing but pi by 4. Easy question. So both x and y is greater than 0 and xy is less than 1. So this formula to be used, tan inverse of x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Now this is equal to tan inverse 1, which is nothing but tan 45 is 1. So tan inverse 1 is pi by 4. Okay, we have already discussed this formula also. We already know. When x and y are both less than 0, then the formula becomes x is less than 0, y is less than 0 and xy less than 1 means formula is this one. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Similarly here tan inverse minus pi plus tan inverse, this value is when x is less than 0, y is less than 0 and xy is greater than 1. Proof is similar to how we solved in previous. So it is exactly same. And the next set of formula is tan inverse x minus tan inverse y. That is a minus b. Tan a minus b is tan a minus tan b by 1 plus tan a tan b. That is x minus y by 1 plus xy. again when both are less than 0. Now this is the formula. Now the next set of formula is 2 tan inverse x. What is 2 tan inverse x? In terms of tan, sin as well as cos. We already learned how to convert between trigonometric ratios and inverse trigonometric ratios. So here tan inverse 2 tan inverse x is nothing but tan inverse of 2x by 1 minus x square. Proof is actually very simple. Just substitute x equal to tan theta. Then what will be the left hand side? That is 2 tan inverse of tan theta. Tan inverse tan theta is theta. So left side is actually 2 theta. Right hand side, x equal to tan theta means 2 tan theta by 1 minus tan square theta. That is nothing but tan 2 theta. So tan inverse of tan 2 theta, again 2 theta. Both left and right hand side is same. Answer is same. Again for this, when x equal to tan theta, 2 tan theta by 1 plus tan square theta. That is nothing but sin 2 theta. Sin inverse of sin 2 theta, again 2 theta. Cos inverse 1 minus x square by 1 plus x square. Again 1 minus tan square by 1 plus tan square theta is cos 2 theta. So cos inverse of cos 2 theta is again 2 theta. Next we will solve one example. Find the value of sin inverse minus 3 by 5 minus cos inverse 3 by 5. Now what is sin of? Sin inverse minus 3 by 5 is nothing but sin inverse minus x is minus of sin inverse x. So we can write minus of sin inverse 3 by 5. And minus cos inverse 3 by 5, that is nothing but we can take minus outside. So this will become sin of minus of sin inverse 3 by 5 plus cos inverse 3 by 5. What is sin inverse x plus cos inverse x, students? Pi by 2. So minus of pi by 2. Sin of minus pi by 2. What is sin minus pi by 2? Minus 1. So answer is minus 1. Okay, next we need to prove this statement. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse of 31 by 17. Proof is again very simple. First we need to write this 2 tan inverse x in terms of tan inverse. We can't have any scalar multiple here. So we need to convert this first. What is 2 tan inverse 1 by 2? 2 tan inverse 1 by 2 is equal to 2 tan inverse x is equal to tan inverse of 2x, that is 2 into 1 by 2 divided by 1 minus tan square 1 minus x square, that is 1 by 4. So this is nothing but tan inverse of 2 tan inverse x is tan inverse of 2x by 1 minus x square, that is 2 into x, 2 into 1 by 2 divided by 1 minus 1 by 2 square is 1 by 4. So this is in numerator we have 1, in denominator we have 4 minus 1 is 3 by 4. So this will be 4 by 3. Now what is 2 tan inverse x? This is 2 tan inverse 1 by 2 plus tan inverse 1 by 7. That is nothing but tan inverse of 4 by 3 plus tan inverse of 1 by 7. This is nothing but tan inverse x plus tan inverse y is nothing but tan inverse of x plus y 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. Now remember, when we add these two, tan inverse x plus tan inverse y, both numbers are greater than 0 and this product is 4 by 21, which is less than 1. So we can use this formula. Always remember which condition is satisfied by this given question. So based on that we have to choose the formula and apply accordingly. So here tan inverse of this value is coming. This is equal to tan inverse of, this is 28 plus 3 31 divided by 21 divided by 21 minus 4 is 17 divided by 21, which is nothing but 31 by 17. Tan inverse of 31 by 17, that is right hand side. So answer tan inverse of 31 by 17. That's how we should solve these questions. Again, another interesting question. Prove that tan inverse of square root of 1 plus x plus square root of 1 minus x divided by square root 1 plus x minus square root 1 minus x equal to pi by 4 minus half cos inverse x. Here x is given as between minus 1 by root 2 to 1. See the solution. Substitute x equal to cos theta. When we substitute x equal to cos theta, then this value is inside the tan inverse term become root of 1 plus cos theta plus root 1 minus cos theta divided by denominator. Substitute x equal to cos theta. What is 1 plus cos 2 theta, students? 1 plus cos 2 theta is 2 cos square theta. So what is 1 plus cos theta? 2 cos square theta by 2. That is root of 2 cos square theta by 2. That is nothing but mod of root 2 cos theta by 2. Similarly here 1 minus cos theta is root 2 sin theta by 2. Why? 1 minus cos 2 theta is 2 sin square theta. So this value is root 2 sin theta by 2 in modulus. Same in denominator. Now root 2 is common in both, so we can cancel out that. Remaining what we have, mod cos theta by 2 plus mod sin theta by 2 divided by mod cos theta by 2 minus mod sin theta by 2. Now what is given here? X lies between minus 1 by root 2 to 1. Now what is cos x and sin x from this? X lies between minus 1 by root 2 to 1. X is nothing but cos theta. We are substituting x equal to cos theta. So what is cos theta here? Minus 1 by root 2 to 1. So what is theta from this? Theta will be cos 0 is 1 and cos 135 is root 2. So angle is between 0 to 135. That means in this region, what will be sin as well as cos value? Sin is positive in this quadrant. So we can take sin theta as it is root 2 sin theta by 2 minus root 2 sin theta by 2. Just substitute modulus sin theta, this value will be positive here and cos theta will become negative. So cos theta is minus of mod minus x, that is minus of this x. So here also it is minus and this value is written as it is. From this we can take minus outside and cancel out. So we can get minus cos theta by 2 plus sin theta by 2 divided by minus minus. We can cancel out minus, take common and cancel. Then we will get sin minus cos minus sin divided by cos plus sin. Now when we divide by cos theta by 2, this will be 1 minus tan by 1 plus tan, 1 minus tan theta by 2 by 1 plus tan theta by 2. What is that, students? We can write this 1 as tan pi by 4. We know tan 45 degree is 1. So this is tan A minus tan B divided by 1 plus tan A tan B. That is tan of A minus B, that is pi by 4 minus this value theta by 2. So this is nothing but tan inverse of tan of pi by 4 minus theta by 2. What is tan inverse tan theta? Theta. So this is nothing but pi by 4 minus theta by 2. Now what is theta? X equal to cos theta means what is theta? Cos inverse x. Substitute theta equal to cos inverse x. That's it. Pi by 4 minus half cos inverse x. This is about this unit, students. So it is actually a very interesting topic. Once you spend time in this chapter, solve more and more problems, it becomes more and more interesting. We will go to next topic now. Another interesting chapter is matrices. discuss what is the matrix and basics of matrix and start from that. Another very easy as well as interesting topic. You can get surely many questions from this chapter. Next topic is matrices. Okay, what is a matrix? First we need to know why we need to learn this chapter. Matrix is nothing but arrangement or orderly arrangement of certain numbers or elements or some letters or alphabets, whatever is. We are arranging, making a table. In tabular form, we are arranging some elements in the order. And it can denote anything. It can be having some meaning or it can be meaningless also. As long as it is forming a certain pattern, we can call that as a matrix. So matrix is nothing but an arrangement or list of elements in some rectangular order in an array. Why do we need to learn this matrix? We will discuss it with an example. First, introduction. Okay. Consider two variables. Linear equation in two variables. We already know how to solve this. What is the solution for the students? 2x plus 3y equal to 5 and 4x plus 5y equal to 9. We have many methods to solve linear equation in two variables. One is by elimination method, substitution method, just substitute some value, cross multiplication method. We have many methods to solve linear equations. Now what is the solution for this? X equal to 1, y equal to 1 means 2 plus 3 is 5, 4 plus 5 is 9. That means x and y should be 1. So that is the answer. We can solve this easily. Suppose we want to find 3 equations with 3 unknowns. Then how to solve? Again we have many methods like matrix method, determinant, Cramer's rule, and we have many solutions for finding this. But as long as we can eliminate, solve two equations, substitute some value and try to find another equation, we have many methods to solve, but it takes time generally. Suppose instead of 3 elements we have 5 rows, 5 unknowns and 5 equations, then how to solve? We have 1000 equations and 1000 unknowns, then how to solve? These are all trivial basics, but why do we need to solve that first? Because whenever we have huge amount of data, we need to solve that for finding certain element. It will be especially useful in computer science application. We have lots of application based on matrix in statistics, in accounting, in robotics. So there is a lot of application involving matrix. Not just by solving equations. We can form a database using matrix. We have an array in computer programming, you learned in many programming, C programming, Python, you learned arrays. So that is nothing but a list of elements. Again, that involves matrix concepts. So it is nothing but a storage or arrangement of elements in a certain order. So that is why we are learning this chapter, matrix, and some basic properties and computations involving matrices. Again, we have 3 equations and 3 unknowns x, y, z. Then how to solve? We have many methods. So these are all some examples, applications involved in daily life. One is robotics, business economy, computer based application, that is what I told, statistics, accounting. We have lots of programming involving matrices. When we need to solve large amount of equations, like when we want to solve the roots of equation of n degree variable, then we can use matrix. There are a lot of application involving this. Okay. Now what is a matrix? Matrix is nothing but an arrangement of elements in some row as well as order, in columns. It need not have any meaning, or it may be numbers or letters or symbols or anything. Now matrix is an arrangement of complex numbers. That is, complex numbers in itself include real numbers also. So it can be real or complex, imaginary numbers. Matrix is an arrangement of complex numbers in a rectangular array. Rectangular array means it is forming some rows and columns of horizontal lines. What is a horizontal line? This is called a row, and vertical lines. Vertical line is called column. Arrangement of elements in horizontal as well as vertical order is called a matrix. So this is consisting of equal number of numbers. For example, 1, 2, 3, 4, 5, 7. What does this mean? We have here 3 horizontal lines, that is 3 rows, and 3 vertical lines, that is 3 columns. The arrangement of numbers in the matrix is enclosed by the bracket. Either we can use a parenthesis or square bracket. Matrix can be represented in both these ways. Or sometimes they may also represent matrix with the symbol double line. All are matrix only. Matrix denotation can be expressed in all these variants. Now in general, matrix is denoted by capital letters. That is A, B, C, X, something like that. Now the numbers in the matrix are called elements of the matrix. For example, in the previous case we seen arrangement of numbers 1, 2, 3, 4, 5, 6. Those numbers 1, 2, 3, these are called elements of the matrix, which are generally denoted by small letters. That is A, B, C, X. Some small letters is generally denoting the elements, and capital number represent the entire matrix. Okay, horizontal line is called row and vertical line is called column. For example, this 2, 3 is a row, 4, 5 is a row, 2, 4 is a column, 3, 5 is also another column. Now generally rows and columns are numbered like R1, that is row 1, row 2, R2, C1, column 1, C2, column 2. Likewise, we generally denote rows and columns. Okay, next, notation of rows and columns. 1, 2, 3, that's what I told. This is R1, R2, R3. Similarly, column 1, column 2, column 3. So this is how we represent matrices. Now what is order? Just now we have discussed what is a matrix and how to write elements in the matrix, and what are the rows, what is a row and what is a column in the matrix. Now we will discuss what is order of a matrix. Order of matrix is nothing but representation of number of rows and columns in a certain manner. That is, matrix with m rows and n columns is generally denoted by order m by n. M cross n. We generally read it as m by n. Matrix of order m by n. Matrix of order 3 by 2. That means 3 rows and 2 columns. M by n means m rows and n columns. Order of matrix is known as, either we can say it as type of matrix or order of matrix or size of matrix. There are different ways to say order. Generally we prefer to write order. Now what is, suppose this is a matrix, how many rows and columns are there in this matrix? 1, 2, 3 is a row 1, 4, 5, 6 another row, 7, 8, 9 is another row. Remember, horizontal line is row, vertical lines are called columns. How many columns are there? 3 columns, and rows 3 rows. So number of rows is 3, number of columns is again 3. Now what is the order of this matrix? Order is nothing but row by column, that is nothing but 3 by 3. So order of matrix is 3 by 3. Next is, in general we write the previous matrix denoted by A in a bracket, small a ij. Now what is this ij mn? We already learned what is m, number of rows, n, number of columns. When we write a square bracket and write m by n, that means this is number of rows by number of columns. A matrix of order 3 by 2 means that has, a matrix has 3 rows and 2 columns. Now what is this aij? We already know A means element, small a denote elements in the matrix. And what is this ij? I is a row number and j is column number. For example, a matrix has 3 rows and 2 columns. That means I varies between 1 to 3 and j varies between 1 to 2. By varying I and j, we have different elements generated. That means A1, 1. That means first row, first column, element in first row, first column. A1, 2. That means first row, second column. A1, 3. First row, third column. Similarly, we can form elements. And remember, this number I and j cannot exceed the row number and column numbers, because matrix only has n rows and n columns. We can't go beyond that. There won't be any element outside this. Now expanded form of matrix. That's what we discussed. A11 means row number, column number. A12, A13, A1n. That means this number of columns is n. So 1 means first row, first column, first row, second column, first row, third column, first row, nth column. Similarly, A21, 22 up to 2n. How many rows are there? M rows are there. That means this is M1, M2, M3 up to Mn. This is the general expansion of matrix, representation of matrix. Totally how many rows? M rows are there. Count 1, 2, 3 up to M, and columns are n columns. Order of matrix is m by n. That is given here. Okay, next. Matrix A is given like this. The number of rows in this matrix is, obviously number of rows means these two are called rows. Then its total number of rows is 2 rows are there in this matrix. So option 2 is the correct answer. Order of matrix. Again, order of matrix is written by number of rows by number of columns. So how many rows are there? 2. Number of columns? 3. So answer is 2 cross 3. That is 2 by 3. Again, what is the order of this matrix? 3 rows, 2 columns. That means order is 3 cross 3 by 2. That is first option. Now we go to types of matrices. Again, another important and interesting topic, types of matrices. What is a square matrix? A square matrix is a matrix which has equal number of rows as well as columns. So a matrix is said to be a square matrix if the number of rows and number of columns are equal. That is, for example, m equal to n. That means generally we write square matrix bracket Aij of 3 cross 3, 3 by 3, 2 by 2, 4 by 4. Matrix of such types are called square matrix. In general, instead of writing 3 by 3, 2 by 2, we generally denote square matrix order as a matrix is a square matrix of order 2, of order 3. That means it is 3 by 3 matrix, 2 by 2 matrix as such. For example, this matrix has 2 rows and 2 columns. As number of rows and columns are equal, this is an example of square matrix. Number of columns is 2, so this is a square matrix of order 2. Generally we write order as just order number, because both these numbers are equal, we just write it once. Next is a rectangular matrix. What is a rectangular matrix? Any matrix that is not a square matrix is called a rectangular matrix, as simple as that. So when number of rows and columns are not equal, it becomes a rectangular matrix. That is, m is not equal to n. Example, here number of rows is, there are 2 rows. How many columns are there, students? 1, 2 and 3. There are 3 columns and 2 rows. So totally 2 by 3, that is 2 by 3 matrix order. Therefore as m is not equal to n, this is not a square matrix, or we can call it as rectangular matrix. Okay, next is, what is a principal diagonal? We call principal diagonal or main diagonal or leading diagonal. All these terms denote the same thing. So we can also write this as, instead of principal diagonal, we can write this as leading diagonal or main diagonal. Principal diagonal, leading diagonal or main diagonal, all these things are representing same thing. So what is a principal diagonal? It is nothing but the value of elements that has I equal to j. That is number of row number and column number are same. Elements of such types are called principal diagonal elements. Okay, we will see with an example. That is I equal to j. Example, we have a matrix like this. First thing, this diagonal, principal diagonal exists only for square matrix. For any rectangular matrix, we can't talk about diagonal. It only exists for square matrix. We should be clear about that. Then, for example, this is the given, okay, we have this. Now what is the principal diagonal of this? Principal diagonal is nothing but I and j number should be equal. That means a11, a22, a33. What are the elements in that? A11 means first row and first column. That will be this element. First row and first column. Then what is that? First row, second column, it is not a diagonal element as I is not equal to j. Then second row, second column will become diagonal element. And what is second row, second column? Second row, second column, this element. Third row, third column. Which means when we draw a line from left to right diagonally, the elements comprising of this is called principal diagonal elements. So what is a principal diagonal element or leading diagonal or main diagonal element? 2, 4 and 6 are the leading diagonal elements of this. That is A11, A22, A33. Similarly, okay, next 2, 4 and 6 are leading diagonal elements or diagonal elements. Next, what is a trace of a matrix? Again, this is an interesting topic. What is a trace? Trace is nothing but sum of diagonal elements. Sum of leading diagonal elements. That is called a trace of matrix. That is nothing but summation of A A11 plus A22 plus 33 plus up to n. This is a matrix of order n. Order n. Example, this is a matrix given as such, and what is the trace of this matrix? Trace is nothing but we have to add these values, that is 2 minus 1 plus 9. Don't take the absolute value, just add whatever is inside, that is 2 minus 1 plus 9, that is 1 plus 9, 10. So trace is 10. Trace is 10. Next, what is a diagonal matrix? Remember, recall whatever we discussed up to now. What are the types of matrix we have seen till now? Square matrix. What is a square matrix? Number of rows is equal to number of columns. Then what we discussed? Rectangular matrix. Any matrix which is not a square matrix is called a rectangular matrix. Then diagonal. What is a diagonal of a matrix? This is existing for only square matrix, and diagonal elements are nothing but when I and j are equal, that is row number and column number are equal, those elements are called diagonal elements. And when we add all the diagonal elements, that is trace of a matrix. Now we will discuss what is diagonal matrix. Diagonal matrix is nothing but except the diagonal elements, all other elements become 0. That type of matrix is called diagonal matrix. So if each non-diagonal element of a square matrix is equal to 0, such matrix is called diagonal matrix. For example, except diagonal elements, remaining elements become 0. So, if one element of the diagonal is 0, then will it be a diagonal matrix or not? Obviously, it is a diagonal matrix. We can have 0, 0 here. As long as any one element is not 0, we can tell this matrix as diagonal matrix. Remaining elements, all the elements should be 0. That is a mandatory condition. So, is this a diagonal matrix or not? Obviously, it is a diagonal matrix. Okay, except diagonal elements, remaining elements become 0. Next is a scalar matrix. Again, a scalar matrix is a diagonal matrix, but all the diagonal elements are same. And it is non-zero number. Scalar matrix is a diagonal matrix with diagonal elements is same or non-zero numbers. A scalar matrix is said to be, a matrix is said to be, square matrix is said to be scalar matrix such that Aij equal to 0 for I not equal to j. That means it is a diagonal matrix. And Aij equal to k. That means A11 equal to k, A22 equal to k for I equal to j. That means all the diagonal elements become same and non-diagonal elements become 0. Where k is any scalar. For example, in this example, 0 is non-diagonal element, so all the non-diagonal elements are 0. And what about diagonal elements? It is the same element too. Therefore, this is an example for scalar matrix. Next is a unit matrix. Again, unit matrix is also a scalar matrix such that all the diagonal elements are unity, that is 1. So, if each non-diagonal element is 0 and diagonal elements become 1, that is a unit matrix. Unit matrix is also called identity matrix. Okay, a square matrix is said to be a unit matrix if Aij is equal to 0 for I not equal to j. That means all the diagonal, non-diagonal elements become 0 and Aij equal to 1. That means all the diagonal elements is 1. We denote unit matrix in general by the letter I, capital I. I2, I3, I4. That means this is I is a unit matrix of order 2. In means I is a unit matrix of order n. This is a unit matrix of order 2. Therefore, we can write this I2. Okay, this is written as I2. Next is a zero matrix. We call zero matrix, null matrix, void matrix, empty matrix, all are same. So what is a zero matrix, students? All the elements in the matrix become 0. That is a zero matrix. Obvious, it is very easy. So all the matrix element, if each element in the matrix is 0, such matrix is called zero matrix. We just write O or 0, that is a zero matrix. We write O2, that is zero matrix of order 2. O3, zero matrix of order 3, or simply write 0, that is zero matrix. This is O 3 by 2, that is order 3 by 2, zero matrix of order 3 by 2. Remember, zero matrix need not be scalar or diagonal matrix or square matrix. In general, zero matrix is not a square matrix. It can be of any order. As long as it is a square matrix, we just write one number, otherwise we just write the row and column order as such. Next is a row matrix. What is a row matrix? A row matrix is a matrix that has only one row. Columns can be n number of columns, it can be any number of columns. So as long as a matrix has only one row, this matrix is called row matrix. For example, 1, 3, 2. This matrix has only one row, so this is a row matrix. As this has only one row, this is a row matrix. What is the order of this matrix? 1, 3. 1 by 3. This is the order of the matrix. Next is column matrix. Now what is a column matrix? A matrix with only one column is called a column matrix. Just like what is a row matrix? A matrix with only one row. Column matrix is a matrix with only one column. So a matrix with only one column is called a column matrix. That means rows can be n number of rows. So what is the order of column matrix? Can you guess, students? Order is nothing but m rows and one column. This is a column matrix example. How many rows are there? 2 rows. How many columns is there? 1 column. So this is nothing but column matrix of order 2 rows, that is 2 by 1. 2 rows and only 1 column. What is the order? 2 by 1. That's it. Next is triangular matrix. Till now, how many matrices we discussed? Square matrix, rectangular matrix, diagonal matrix, diagonal element. What is diagonal element? And trace of a matrix. And then we have discussed what is a scalar matrix, unit matrix, row matrix, column matrix. And now we are coming to triangular matrix. Again, triangular matrix is a diagonal matrix. Not exactly diagonal matrix, it is part of a diagonal matrix. General, we will discuss. Triangular matrix have two types, two variants. One is upper triangular or lower triangular or just triangular matrix. What is the condition for triangular matrix? Except the diagonal elements, if the lower part of diagonal element becomes 0 or upper part of element becomes 0 or both become 0, such matrix is called triangular matrix. What I mean by this is, let's see an example and you will understand. In this example, observe, all these elements become 0. What is this? Diagonal element. All the elements below the diagonal becomes 0. That means this is a triangular matrix. Suppose if all the elements above the diagonal become 0, that is also a triangular matrix. As long as any one area below diagonal or above diagonal becomes 0, that is a triangular matrix. If both become 0, this becomes a diagonal matrix, obviously. Here all the elements below this diagonal become 0. That is all these positions where I is greater than j. What is I? Row number. This is 2, 1. 1 is less than 2. 3, 1. Again 3 greater than 1. 3 greater than 2. This type of representation, I greater than j, means it denotes all the elements below the diagonal. I is less than j means it will give all the elements above the diagonal. Either in all these positions I greater than z becomes 0 or I less than z, that is above the diagonal elements. This region becomes 0. Then this matrix is called a triangular matrix. Okay. In particular, this matrix is also called upper triangular matrix. Why do we call this upper triangular matrix? Because only in this region forms a triangle. Yes or no? This region forms a triangle and the elements below the triangle becomes 0. That means this triangle is formed by the upper triangular elements, region above the diagonal elements. That's why it's called upper triangular matrix. Then can you guess, suppose if the above the diagonal elements become 0, what will be this matrix called? Matrix with the diagonal elements and below the diagonal elements, that will be called lower triangular matrix. So that is upper triangular. Next one is lower triangular matrix. What is the condition? I is less than j. That means all the elements above the diagonal elements become 0. This type of matrix is called a lower triangular matrix. All the positions are this. I is less than j, all the elements become 0. Next one, a matrix is said to be a triangular matrix as long as it is either upper triangular or lower triangular. If any one condition is satisfied, we can call that matrix as, in general, triangular matrix. I will again repeat. A matrix which is both upper triangular, either upper triangular or lower triangular. If any one of the region either above the diagonal or below the diagonal becomes 0, such matrix is just called a triangular matrix. We need not specify if it is upper triangular or lower triangular. For example, this matrix is called a triangular matrix. In specific, if you want to call what is this matrix, it is a lower triangular matrix. And this is an upper triangular matrix. In general, we call both these matrices just triangular matrix. Now, what will be the matrix that is both upper as well as lower triangular? Then above the diagonal as well as below the diagonal elements become 0. Which means only diagonal elements are non-zero. What is that matrix? Students, remember what is the matrix which has all the elements except the diagonal elements is 0? Yes, it is diagonal matrix. So diagonal matrix will be also a triangular matrix. Yes or no? These are all triangular matrix. If a matrix is both upper as well as a lower triangular, this matrix will be diagonal matrix. This is an example for diagonal matrix. It is an both upper as well as lower triangular matrix. Or we can also call this as a just triangular matrix. Okay, next. A matrix is given. What is the trace of this matrix? Easy question. Remember what is the trace of matrix? We just need to add all the diagonal elements. Sum of diagonal elements of a matrix is called trace. What is sum of diagonal elements? 1 plus 5 plus 9, that is 14, 15. Answer should be 15. So option 2 is the correct answer. Yes, very easy questions. Next question. Which of the following is a scalar matrix? Okay, again we have 4 options. Which of the following is a scalar matrix? What is the condition for scalar matrix? Scalar matrix is a diagonal matrix and diagonal elements are all same number, which is non-zero. Now observe, all these matrix or diagonal matrix are not first. This is obviously not a diagonal matrix because we have some other elements in other region except diagonal. This is also not a diagonal matrix. This is a diagonal matrix as well as this is a diagonal matrix. So option 1 and 2 are diagonal matrices. What is a scalar matrix? All diagonal elements should be same number. So which option should be correct? Option 2. Next one. Which of the following is a triangular matrix? Easy question. If this is a triangular matrix or not. What is the condition for triangular matrix? A matrix which has elements above the diagonal is 0 or below the diagonal elements is 0. Here this matrix has all the elements above the diagonal elements as 0. This matrix has all the elements below the diagonal element as 0. That means both are triangular matrix. So what is the option? Both 1 and 2. Next topic is equality of matrices. Equality as well as sum of matrices. Now what is a matrix equality? That means when we compare two matrices are said to be equal when those two matrices have exactly same order and each element, corresponding element should be same. What does that mean? Two matrices is exactly equal on two conditions. What are the conditions, students? One is both matrices should have same order. If two matrices have different order, then there is no comparison between the matrices. Just we need to ensure if both matrices have same order or not. Next condition is corresponding elements are all same. That means suppose matrix A and B. Let's take the element of first matrix A as Aij. Second matrix B as Bij. That means Aij should be equal to Bij. A1, 1, 1, 2, 2, 3. For example, this is a matrix A and this is matrix B. First we need to see if both the matrices have same order or not. Obviously, these two matrices have how many rows? 2 rows. How many columns? 3 columns. So these two matrices have both 2 rows as well as 3 columns. So order is 2 by 3. So both matrices have same order. Then what we need to see? Compare the elements. These two matrices will be equal when A11 equal to B11. That is first element here. That should be equal to element here. A12 equal to B12. These two elements should be equal. A12 should be B12. A13 is equal to B13. A21 equal to B21. A22 equal to B22. A23 equal to B23. When both these elements are equal, then we call these two matrices as equal matrix. First we check order of both the matrices. Both matrices have order 2 by 3. Then what we need to do? Check the elements. Aij is equal to Bij. That is A11 equal to B11. Similarly, we should check for other. Now what is sum of two matrices? Remember, when we need to add two matrices, again the first condition is both matrices should have same order. Only then we can add or subtract two matrices. Now when two matrices have same order, then for equality what we did? Both the corresponding elements of two matrices are equal. For sum or addition of two matrices, just add the corresponding elements. It's as simple as that. So addition of corresponding elements of A and B will give A plus B. That is sum of two matrices. It is denoted by A plus B. Matrix A plus matrix B. Now Aij and Bij are two matrices with elements as such. Then A plus B will be just Aij plus Bij. Cij is Aij plus Bij. Cij equal to Aij plus Bij. With example, we will understand this. Okay, A matrix and B matrix is given like this. What will be A plus B? We will write A plus B as well as A minus B here. What is A plus B? A plus B is a matrix. First we need to see if both the matrices have same order or not. What is the order of matrix A? 2 rows and 3 columns. So order is 2 cross 3. Second matrix again 2 by 3. That means what we need to do is add the corresponding element. That is 3 plus 1, 4. 2 minus 2, 0. Minus 1 plus 7, 6. 4 plus 3, 7. Minus 3 plus 2, minus 1, 1 minus 1, 0. This is A plus B matrix. This matrix exists only when both the matrices A and B have same order. Only then we can add the corresponding elements. Next, what will be A minus B? Again, this is nothing but Aij minus Bij. As simple as that. Just subtract the corresponding elements. 3 minus 1, 2. 4 minus 3, 1. 2 plus 2, 4. Minus 3 minus 2, minus 5. Minus 1 plus minus 1 minus 7, minus 8. 1 plus 1, 2. This is A minus B. This is how we should find. Find A plus B. A plus B is equal to, just add the two matrices, that will give, add the corresponding elements. 3 plus 1, 4, 0, 6, minus 1, this one. We already know how to find this. We have already calculated this. Next one, properties of sum of matrices. Consider two matrices A and B. Then what are the properties? These two matrices will have same order, and addition of matrices will be adding corresponding elements. First property that satisfies is A plus B will be equal to B plus A. Obviously, when we add two elements, irrespective of what order we choose the first and second element, addition is same. 3 plus 4 is equal to 4 plus 3. It's as obvious that. So A plus B is equal to B plus A. Next, this also follows associative property. A plus B plus C is equal to A plus B plus C. We have three elements, three numbers added, it is same. Next, additive identity. Now what is additive identity? When we add some number to give another number, it should give the same number. That means when we add some matrix to the given matrix, it should result in same matrix for a matrix. So what is the additive identity of a matrix? We add 0 matrix to that. So any number plus 0 gives the same number. For a matrix, 0 matrix is called identity, additive identity. So here 0 is the additive identity matrix. Next one is additive inverse. What is additive inverse? When we add some matrix to the given matrix, it should result in identity. Such matrix is called additive inverse. That is, suppose two matrices are A and B. When we add these two matrices, it should give the answer 0. That is 0 matrix. That means B is equal to minus A. So additive inverse of B is minus A, and additive inverse of A is B. And what is that? A additive inverse will be minus B, that is nothing but minus A. Additive inverse is minus A. Additive inverse of A is minus A, because A minus A will give the 0 matrix. So what we had, A plus minus A equal to 0. So minus A is the additive inverse of A, and A is the additive inverse of minus A. For example, this is a given matrix. A matrix is such that, and find the additive inverse of A. Now what is additive inverse? When we add some number to this matrix, it should give an identity matrix. What is identity matrix? Sorry, 0 matrix. Additive identity. What is additive identity? Additive identity is 0 matrix. So when we add some number to this matrix, it should give 0 matrix. What number should be added to this matrix? Obviously, the additive inverse matrix will also have same order. Only then we can add the two matrices. And then what we need to see? Just subtract this number as such. 1 minus 1 will become 0. Minus 2 plus 2 will become 0. So negate all the elements here. That will give the additive inverse. What is additive inverse of A? Minus A. That is minus of this matrix, which is nothing but multiply minus to all the elements. Next topic is scalar multiple. In the previous example, what we did, minus 1 into this matrix, we have multiplied all the elements with minus 1. Now what is scalar multiple? It is same as that example. Suppose a number k or lambda is there, that is a scalar non-zero number. Then if you multiply that number to a matrix, then all the elements in that matrix will be multiplied by that number. Any non-zero complex number. Let a matrix A be a matrix of order m and n, and k be a scalar. Then the matrix applied by multiplying each element of A is k. Then k is the scalar multiple of A. It is denoted by k into A. Suppose A is a matrix with elements Aij of order m cross n, m by n. Then Ka is nothing but multiply each element by k. That is Kij. Kaij. Okay. K is given, A is also given. What we need to find? Find Ka. What is Ka? Multiply 2a. Find 2a. That is nothing but multiply 2 to all the elements. Ka equal to 2a. That is nothing but 2 times of this value, which is 2 into 3, 6, 4 minus 2, 8 minus 6, 2. Easy question. Next question. A and B matrices are given and 2x plus A is equal to B. Then we need to find the value of x. Till now we have discussed scalar multiple, addition properties, that is commutative, associative properties, existence of identity, inverse, and now we are saving scalar multiple, and using that addition, equality as well as scalar multiple, we are going to solve this question. 2x plus A equal to B, then find x. We don't know x. What we need to do is add minus A to both sides. That means this value 2x equal to B minus A. Which means 2x will be equal to B minus A. That is equal to, what is B minus A? 3 minus 1, 2, 8 minus 2, 6, 7 minus 3, 4, 2 minus 4, minus 2. Now this is B minus A. What is 2x is B minus A. What is x? X is half of this value. So divide by half. 1 by 2 of 2, 6, 4 minus 2. What is the answer? 1, 2 by 2. We have to multiply half to each element. So this is 2 by 2 is 1, 6 by 2 is 3, 4 by 2 is 2, minus 2 by 2 is minus 1. This is the answer x. So 2x is this matrix. What is x? Half of this. X equal to this matrix. 1, 3, 2 minus 1. Okay, next question. This is a very common type of question. You can expect such questions in 2-mark questions in your board exams. Construct a 3 by 2 matrix whose elements are defined by some pattern. They will give some pattern and we should find a matrix. That is, generate a matrix that satisfies the given condition. Now what is I and J? I and J are row number and column number. What is given? Matrix of order 3 by 2. That means how many rows? 3 rows and columns? 2 columns. So what will be the elements? Matrix. I will do it here. A matrix A of order 3 cross 2, 3 by 2 will be how many rows? 3 rows. That is A11, A21, A31. How many columns? 2 columns. That is this one column, another column is 1, 2, 2, 2 and 3, 2. Matrix elements will be like this. Now for finding each of the element, what is the value of the element? Here Aij is defined by half of modulus I minus 3j. Now substitute. What is A11? I equal to 1, j equal to 1. Substitute the values. So A11 is equal to half of 1 minus 3. What is 1 minus 3? Minus 2. Mod minus 2 is 2. 2 by 2 is 1. This is half of I 1 minus 3 modulus. This is nothing but 2 by 2, which is 1. Next A12. A12 is half of modulus of I is 1, j is 2. So 3 into 2 is 6. This is nothing but mod minus 5, which is 5. So answer is 5 by 2. Next, here 2 1. 1 2. I is 2 minus 3. That is 1 by 2. Next, here 3 2 2. 2 minus 6. That is 4 by 2 is 2. Here 3 1. Which is again 3 minus 3 becomes 0. Next, here 3 2. That is 3 minus 6. Which is again 3 by 2. So, what is the required matrix? Matrix A will be equal to, write the elements. A1 1 is 1, A1 2 is 5 by 2. A2 1 is 1 by 2, 2 2 is 2. A3 1 is 0, A3 2 is 3 by 2. This is the required answer. So, this is how we should solve these questions. Don't take more than this value because we already know the order of matrix. In the question they will give the order and they will give the pattern that suits this, and we just need to substitute I and j values and generate the elements. Okay, so what is the answer? Just substitute the values. So all the elements are given listed here, and what is the matrix? 1 5 by 2, 1 by 2 2, 0, 3 by 2. Okay, next question. A is a matrix 1 2 3 4, B is a matrix 4 3 2 1. Then what is A plus B? Obviously easy question. What is A plus B? We just need to add the two matrices. That is 1 plus 4 is 5. So all the three options can be possible. 2 plus 3 is 5. 3 plus 2 is 5. That means option C is the correct answer. Easy questions. What is the additive inverse of this matrix A? Again, additive inverse is nothing but we just need to negate the answer of the matrix, that is minus 4 minus 3 2, minus 4 minus 3 2, minus 1 5 minus 6. Minus 1 5 minus 6. Option 3 is the correct answer then. Yes. Next question. A is a matrix. Find 3 times A. Again, scalar multiple of A. When we have to multiply a number to the matrix, multiply all the elements in the matrix. So what is the answer? 3 into 2 6, 9, 18 and 3 15 minus 18. So what is the answer? 6 9 18, 3 15 minus 18. Easy questions. Next, if two matrices are given, find x, y and z and a. I think question is incomplete. Actually, these two matrices are, let's take these two matrices are equal. I think question is incomplete. Yes, these two matrices are equal. Given these two matrices are equal, this matrix is equal to this matrix, given matrix is equal to 5 2 minus 2 a minus 4. Now we need to find all the values x, y, z as well as a. Now what is the condition? First step is to identify the order of both the matrices. If order is same, only then we can add the matrix. Sorry, equate the matrix. Now what is the order of this matrix? There are 2 rows and 2 columns. This matrix also has 2 rows and 2 columns. As the order of both the matrices are same, that means we can equate the elements. Now when we equate the elements, that is x minus 3 is equal to 5. Then what is x? 8. Again 2y minus 8 equal to 2. What is y? It will be 5. Correct? Now 2y equal to 10. Y equal to 5. Z plus 2 is equal to minus 2. So z will be minus 4. We will see the solution. equate corresponding elements, that will be x plus x minus 3 equal to 5, 2y minus 8 is equal to 2, and z plus 2 is equal to minus 2, 6 equal to a minus 4. Which means what is x? X equal to 8. What is y? Y will be 5. What is z? Minus 4. What is a? 6 plus 4 is 10. So this will be the answer. Next topic is multiplication of matrices. How to multiply two matrices? We can multiply two matrices when we have the number of column in the first matrix and the number of rows in the second matrix are equal. That means, I will tell with one example. Say that we have to find A into B. Let A matrix be of order 3 by 2. B matrix is of order 2 by 2. Then can we multiply these two matrices? How to ensure, how to identify if we can multiply the matrices? We have to see the column of first matrix and row number of second matrix. If these two values are same, then we can cancel out this and we can find the AB matrix. AB matrix will be of order. Take the row number of first matrix and column number of second matrix, that is 3 by 2. This will be the answer. Suppose A is a matrix of order 3 by 4. B is a matrix of order 3 by 2. Then can we find AB? AB cannot be found because first matrix is of order, has number of columns 4, second matrix has number of rows 3. If these two numbers are not equal, then we cannot multiply the matrix. This is the basics of matrix multiplication, product of two matrices. Suppose this value is 3. Again we can find AB. AB is not possible. Not possible. Now what about B into A? B into A will be, B matrix is of order 3 cross 3 and A matrix is of order 3 cross 4, which implies we can find BA matrix. Here number of rows in the first number of columns in the first matrix and number of rows in the second matrix are both same. That means BA matrix will be of order. Take the number of rows of first matrix and columns of second matrix. That will be 3 cross 4. How to multiply two matrices? Matrix A and B are conformable. What is the meaning of this word conformable? That means we can find the product. It is possible for multiplication if the number of columns in the first matrix is equal to number of rows in the second matrix. Let A and B be two matrices, C be another matrix. What will be the order of C matrix? Take the number of rows in the first matrix and number of columns of second matrix, that is M cross M by P. This is the product of matrix A and B. Okay. This N will be cancelled out, remaining M and P will be remaining. Okay, C matrix is nothing but Aij into Bjk. What does this mean? We will discuss this with an example, then it will be easy to understand. It is just denoted by A into B, that is AB. For example, we take these two matrices. Matrix A is 1, 2, 3, 3, 2, 1. Matrix B is 1, 2, 3, 4, 2, 0, 1, 2, 1, 3, 4, 0. Now matrix A has the order 2 cross 3, 2 by 3 and matrix B has the order 3 by 4. Now how to multiply these two matrices? First we need to see if the matrix is multiplicable or not. How to check? Take the number of columns of first matrix, that is 3, number of rows of second matrix, both these values are same. That means we can cancel out this. What will be the order of the resultant matrix? That will be 2 cross 4, 2 by 4. Therefore, these two matrices multiplyable. AB is existing, possible. And how to multiply? The procedure for multiplication is as simple as just multiply corresponding row and columns of both the matrices. Take the element A11, B11, A12, B21. Multiply in corresponding order. What is the matrix AB? AB has, we have suppose AB11. Let's take what is the order of this matrix? 2 cross 4. AB matrix is of order 2 cross 4. That means there is 2 rows and 4 columns. Now how to write the elements? That means let this be AB11. How many rows are there? 2 rows and 4 columns. So AB13, AB14. Similarly AB21, there will be 4 elements in second row. AB24. Now how to find these elements? AB11, that means take this number first, 1 and 1. That means what we need to do is, this first number represents row number of first matrix, and the second one represents column number of second matrix. That is, this is first row, take this, and this one represents column number, that is column of second matrix. This one is row of first matrix, column of second matrix. That is the resultant row of first matrix by column of second matrix. So what we do is, take this row of first matrix, first row, and column of second matrix. Now how to find this value AB11? What we need to do is, just multiply the corresponding elements of this row and column and add. That is it. That means 1 into 1, that is 1. 2 into 2, that is 4. 3 into 3, 3 into 1, that is 3. So add all these values. 1 into 1 plus 2 into 2 plus 3 into 1. For example, what is AB12? That means take the first row and second column. Now 1 into 2, 2 into 0, 3 into 3. Similarly, find all the values. What will be 2, 4? Take the second row and fourth column. 3 into 4, 2 into 2, 1 into 0. Multiply the corresponding elements. That is it. Let's see the solution. How to multiply? Multiply 1 into 1, that is 1. 2 into 2, that is 4. 3 into 1, that is 3. And add all the values. Next one, 1, 2. AB1, 2. That is, take the first row and second column. That will be 1 into 2 plus 2 into 0 plus 3 into 3. Next, 1, 3. That is first row and third column. That is 1 into 3, 2 into 1, 3 into 4. So this is the answer. Similarly, find the other values. Okay, this is the answer. Now add all the values. That is the matrix AB. What is the matrix AB? 1 plus 4 plus 3, 8. 2 plus 9, 11. 3 plus 2 plus 12, 17. 4 plus 4, 8. Similarly, find the other values. Now, properties of matrix multiplication. I hope you are clear with how to multiply two matrices. Now, we will go to properties of matrix multiplication. The product matrix exists, AB matrix exists if the number of rows in the second matrix and the number of columns in the first matrix is same. And AB matrix exists does not mean BA matrix also exists. For example, this matrix has the order 2 by 2. Number of rows is 2. Number of columns is also 2. Number of rows is 2. Number of columns is also 2. Order is 2 cross 2. This is 2 cross 2. Next one. B matrix is, what is the order of B matrix? There are 2 rows and 3 columns. So order is 2 by 3. It is not displaying here properly. Let me write 2 cross 3. This is 2 cross 2. Now what is AB matrix? See if it is possible or not. What is the condition for AB matrix? Number of columns in the first matrix and row in the second matrix is same. So order 2 by 3 will be possible. Now AB matrix is, we can multiply these two matrices. And how to multiply? AB 1 1, that is first row, first column, 1 2 means first row and second column, correspondingly multiply the elements. So answer will be this. Okay, what about BA matrix? What is B matrix? This one order is 2 by 3. B matrix has order 2 by 3. What is A matrix? A matrix has order 2 by 2. 2 by 2. Here we observe number of columns in first matrix and number of rows in the second matrix. Both are not same. That means this is not possible. We can't cancel out these two. So BA does not exist. So number of columns in B matrix is 3. Number of rows in A matrix is 2. As these two values are not same, it is not possible to find BA matrix. So what we understand is AB matrix exists and BA matrix does not exist for this example. Or sometimes BA matrix exists, AB does not exist. Or sometimes both the matrices can exist. When both the matrices will exist, only when matrix is square matrix. Both are square matrix. Only then AB matrix can exist. Even if AB and BA exist, the values of both need not be equal. And they need not be of same order also. For example, A matrix is 3 cross 2, B matrix is 2 cross 3. What will be AB matrix? That will be 2 will get cancelled, 3 cross 3. What will be BA matrix? That will be 2 cross 2. Which means order is not same, which means obviously AB and BA are not equal. Now AB and BA are not of same order, they need not be equal. Again, A matrix and B matrix, both of, what is the order of these students? A matrix has order 2 by 2, B matrix again 2 by 2. Now A matrix is this, B matrix is 2 by 2. Okay, what is the order of AB? AB is again 2 by 2, BA will be again 2 by 2. You know how to multiply two matrices? AB matrix is given by this. What is BA matrix? It is coming out to be this matrix. So what we understand from this example, AB may not be necessarily equal to BA. Now how the questions can be asked? They may ask, give two matrices and prove AB not equal to BA, or verify commutative property or associative property of the matrix. Questions can be asked in that way. So here what is given? Matrix A and B. We took two examples for matrix A and B and try to find AB and BA. Sometimes both the matrices are not possible. Sometimes one matrix exists, AB exists and BA does not exist. or sometimes both the matrices can exist but they are not equal, or sometimes both the matrices can be equal also. That is also a possibility. And sometimes order may not be same for both the product AB and BA, and sometimes order can be same, sometimes matrix itself can be same. So all possibilities are possible. Now what is a matrix multiplication? It is always associative. Just before what we discussed, matrix multiplication AB is not equal to BA means matrix multiplication is not commutative. That is the first property. Second property, matrix multiplication is associative. What is associative property? A into BC equal to AB into C. A into BC equal to AB into C. This is the associative property. Now matrix multiplication is distributive over matrix addition. What does it mean, students? A into B plus C is equal to AB plus AC. Just like how we write in numbers, it is same for matrix also. A into B plus C is equal to AB plus AC, or B plus C into A. We can multiply and add in any way. Answer will be same. This is BA plus CA. Remember, BA and AB are not equal. That means you should not write this matrix as AB plus AC or AB plus CA. That is wrong. So always remember, this matrix should be distributed in the same order. That is the key. Don't interchange this. A into B plus C means A into B plus A into C. This is true. Not BA plus CA or BA plus AC. Right now. So this is matrix multiplication is distributive over addition. Questions can be asked to prove these properties. They will give some matrix examples and ask you to prove. Now, if AB equal to 0, that means for a number, what is the condition? If multiplication of two number is 0, then either one of the numbers should be 0 or both the numbers should be 0. AB equal to 0 means A equal to 0 or B equal to 0. What about matrix? It need not be both the matrices are 0. Sometimes one matrix can be 0, in another way both the matrices can be 0, or sometimes both the matrices are not 0. All the three possibilities are there. So what is meant? AB equal to 0, it is not necessary that A equal to 0 or B equal to 0. We will consider an example. They can ask, take some example for A and B such that AB equal to 0. Two more questions can be asked like that. Find existence of 0 matrix given two non-zero matrices. Product of matrix should be 0. Find any two matrix. Take an example. Questions can be asked like that. So AB equal to 0 is not necessary that A equal to 0 or B equal to 0. A is a matrix 1 0 2 0 and B is a matrix 0 0 3 4. Now what is AB, students? AB is nothing but multiply this. What is the order? 2 cross 2, 2 cross 2, 2 by 2, 2 by 2. So AB matrix will also be of order 2 by 2. A into B. How to multiply? First row, first column. First row, second column. Multiply the corresponding elements and add. When we multiply 1 into 0 is 0 plus 0, 0, 0 plus 0 is 0, 0 plus 0, 0, 0 plus 0, 0. So what is the answer? 0. AB is 0, but A and B are non-zero matrices. Here one row is 0, one column is 0. That does not mean this is 0 matrix. We already know what is 0 matrix. All the elements in the matrix should be 0. Okay, next. AB equal to AC. If AB equal to AC, for a number we can cancel out. That means B equal to C. For a matrix, it is not necessary that B equal to C. AB equal to AC is not necessary that B equal to C. Again, we will take some example. A, B matrix is this, C matrix is given by this. So when we want to find AB and AC, find AB and AC. What is AB? multiply the two matrices, that is equal to 0 plus 0, 0 plus 0, 0 plus 30, 0, 0, 30, 36. Sorry, 0. What is AC? I made a mistake. Okay, it is given wrongly. Printing mistake. What is AB matrix? AB matrix is 1 0 2 0 into B matrix is 0 0 3 4. Now what is the product of these two matrices? 1 into 0 is 0 plus 0 0, 0 plus 0 is 0, 0 plus 0 is 0 and 0 plus 0 is 0. So AB is 0 matrix. Here this matrix is given wrongly. Instead of this matrix we should write B matrix. This matrix should be there here. Next, A into C. A matrix is this one, C matrix is this one. A into C is given by, again multiply this, it comes out to be 0 matrix. 0 plus 0, 0, 0, 2 into 0, 0, 0 plus 0 into 5, 0, 0 plus 0, 0. So it is also a 0 matrix. What we understand from this, AB equal to 0, AC equal to 0, that does not mean B equal to C. So AB equal to AC, both are actually 0 matrix, but B is not equal to C. Next, multiplication of two matrices A and B is possible when? Question. This is a property. First we need to know, we already seen what is the condition for multiplication of two matrices. It is possible when number of columns in the first matrix and number of rows in the second matrix both should be same. That is number of columns in matrix A and number of rows in matrix B. Number of columns in matrix A, number of rows in matrix B. So option C 3 is the correct answer. Second, A and B matrix is given. What is AB? Just multiply. How to multiply? First, corresponding element 1 1 1 2, multiply like that. What is the order of this matrix? 2 by 3. And order of this matrix is 3 by 2. So what is AB matrix? It has order 2 by 2. AB matrix has order 2 by 2. Now what will be the elements of this? When we multiply 2 into 3, 6 plus 3, 9 plus 10, 19. We have 3 options. Next one will be 2 into 1, 2, 3 into 0, 0, 5 into 1, 5. That will be 2 plus 0 plus 5, that is 7. Next one, 4 into 3, 12, plus 1, 13, plus 4, 17. Next one, 4 into 1, 4, plus 0, plus 2, 6. So what is AB matrix? 19, 7, 17, 6. Option 2. Easy questions. This is for solving, finding how to multiply the matrix. This is only for practice. Questions need not be as simple as this. Again, A and B matrices are given. Then what is matrix AB? It is same as previous. Just multiply the two matrices and solve. You can take this question as homework. A and B matrix is given. Find AB and BA. Again, it is same as previous question. Both matrices have order 2 by 2. So both matrices is possible, and just find the order. Multiply and write this. You can take this type of questions as homework. You can solve by yourself. AB and BA matrix. Next question. Find A square. Now A square is nothing but A into A. That means we can multiply the same matrix twice. A square is nothing but A into A, which is nothing but 4, 2, minus 1, 1 into 4, 2, minus 1, 1. This is, what is the answer, students? 4 into 4, 16, minus 2, 14, 4 into 2, 8, plus 2, 10, minus 4, minus 1, minus 5, minus 2, plus 1, minus 1. This is A square. So what is A square? 14, 10, minus 5, minus 1. So just find these values. 14, 10, minus 5, minus 1. Next question, find A power 4. Okay, we will discuss the other questions from the next class. Thank you, students. Endigu endendigu nama tavasya.